Okay, let's move on to example 18. So this is a slope stability problem. Uh, the thing is, slope stability is very, very tricky to test in a exam formatting like a FA exam, because most of the stability analysis we do nowadays is finished by using software, and the hand calculation can get very, very tricky very, very soon. So this is pretty much the only scenario, like a simple kind of a simple mass of soil that's sliding on a straight line. And we all know that in reality, this might not necessarily be the real potential failure surface. It could feel like that. But again, let's just try to understand how to solve this problem. I'm not saying this is very practical one. But so this essentially is a physics problem that to see whether this whole block of soil can slide along this surface. So you can pull out the reference manual. The reference manual have something like F factor of safety is the TFF, or basically the TFF is the resistance over the T MOB, mobile or mobilization, and the TFF is the WM, the weight of the mass or the weight of the soil, time the friction angle, the internal friction angle of the soil, right? So, oh, I'm sorry. So, okay, I take it back. So that's not true. So the T mobile is the weight of the soil time the sine I for S. So the I for S is the slope. So that is how much force that is along this slope because of the gravity, right? So we have 30,036 times sine 20 degree, and you would have about 1038 kilonewton. So that is the mobile force. And for the TFF, the resistance along that surface is C times Ls plus a weight of the mass times cosine I for S times tangent friction angle, right? So basically it has two components. One component is provided by the cohesion of the soil, and another part is provided by the friction angle of the soil. And the only thing we don't know in this equation is the Ls. The Ls is essentially the length of the slope. We don't know the length of the slope, but we do have the height is 15 meter. With this slope, we can easily use some simple trigonometry and figure out the length of the slope, which is Ls. So for our case over here, so basically we have C. The Ls is essentially that H over sine I for S, right? So that is the sine, and plus the everything else we should know from the problem. So H is 15, cohesion, we have a 19.2 kilopascal, and the friction angle is 15 degrees. So if we're going to keep doing this, we have 19.2 kilopascal times a 15 meter over sine 20 degree plus a 3036 times cosine 20 degree times tangent, what is the friction angle, is 15 degree, pretty low. And with that, our resistance is about 1606.5 kilonewton. Okay, so our FS, factor of safety, is 1606.5 over 1038. So this is about 1.54. So factor of safety against the sliding is 1.54. So the B is the correct answer. So again, you can see this is basically a simple physics sliding problem. So yep, that's it for example number 18.